In this video, we'll be looking at the one-way ANOVA in SPSS. And as a reminder, we have our data window here on the left, our output window, which is blank, so we haven't done anything yet, on the right. And we have our sample data here with age, some categorical variables, point of view and sentence type, timing, and rating 1 and rating 2. And for our one-way ANOVA, we are going to have one independent variable with 3 or more levels, and we're going to have a dependent variable that is numerical and specifically something like an interval or a ratio variable. And so we're going to be looking at sentence type here and timing. We can see that we have 1, 2, 3, 4 different levels of sentence type. These are different kinds of sentences in this case, and the timing that people took to read them in. And so the first thing that I want to do here is I'm actually going to make a bar graph. So I'm going to go to Graphs, Legacy Dialogues, Bar, Simplest Find, Define. I'm going to click here, Other Statistics. So I want the means of these. I'm going to put timing in the variable section. I'm going to put sentence type in the category axis field and click OK. So this just gives me a nice visualization of my data. And this can be particularly helpful. It's really the best place to start whenever we're doing any analysis, as we've talked about in other places in this course. But specifically, it also allows us to really have a sense of which groups are higher, or in this case, slower, or which conditions might be faster or less in this case. So now I'm going to get right into my one-way ANOVA. I'm just going to hit Analyze. I'm going to go down to Compare Means. I'm going to go to one-way ANOVA. There's actually more than one way to do one-way ANOVA in SPSS, but I'm just going to show you one way just for the sake of simplicity here. So that's Analyze, Compare Means, one-way ANOVA. And then I'm going to put my condition, my independent variable in the factor section. And then timing, I'm going to put in the dependent list, since that's going to be my dependent variable for this analysis. You'll note over here that we also can get options, so I can click to get some descriptive statistics. And that'll give me those descriptive statistics right along with the rest of my analysis. I can also say that we have places for time contrast, post hocs, and some different things here, so we can see we might recognize the Monfermi test, the Chaffee test, but for now I'm just going to cancel that. We want to remember that we really don't want to run those post hoc tests unless we find a significant result, and I'm not sure whether we will or not. Let's go ahead and say OK and find out. And so we get these descriptive stats for each of the 4 groups. For our ANOVA, we can see that this is definitely significant. It says 0.000, which we can write later on as less than 0.001. Have our F-score, our ANOVA value that we would calculate in step 4 of our hypothesis testing procedure. And we also have our degrees of freedom, both different kinds. And so now that we have our results here, so we know that the ANOVA this is saying that these results are significant. We can reject our null hypothesis. And so we still don't know which means are different. And so we might have some guesses based on the graph, but we want to make sure to be really, really specific here. And so I'm going to actually go back into Analyze. Go back to that one-way ANOVA. We're going to run this again with keeping in mind that in this case, the researchers didn't have any prior predictions about which groups would differ from what direction that would go in. And so that's going to qualify as a post hoc test for making these comparisons after the fact here. And so the one that we went over in class is going to be the Chaffee test. So I'm just going to select that and click Continue and OK. And so here we see that we have our ANOVA again, we got this descriptive scan, we got the ANOVA again, and then we have our post hoc test down here. And so we can see our dependent variables timing just as we wanted it to be. We're doing that Chaffee test. Specifically, I'm just going to pay attention particularly up here. And what we can see is we have these different significance levels. And so here, for instance, remember that we're really looking at all these possible comparisons. And so we can see that we're comparing sentence type 1 against 2, 3, and 4, and then sentence type 2 against 1, 3, and 4. 1 against 2, 3, and 4, 2 against 1, 3, and 4, 3 against 1, 2, and 4, and 4 against 1, 2, 3. And for each of these, we get the mean difference, standard error, and significance level. And so you can see that there's no significant difference between groups 1 and 2 for sentence type 1 and sentence type 2. There is a significant difference between 1 and 3. There is a significance between 1 and 4. And so I could go all the way down here. We already talked about 1 and 2 up here, but there is a significant difference between 2 and 3 and between 2 and 4. And so we can see in both of these cases, 3 is going to be less, or in this case, faster than 1 and faster than 2. 4 is going to be slower than 1, slower than 2, because those numbers are positive. And again, we've already looked at this relationship between 3 and 1, 2 and 3, and here we have 3 and 4. We can see that's also significant as it is over here and over here. 4 is going to be slower than 3. And then most of these we've seen at this point. So we have 4 and 1, 2 and 4, and 3 and 4. So that really covers the rest of this. And so overall, we can see that group 3 is going to be faster than all the other groups. Group 4 is going to be slower than all of the groups. And there's no significant difference between group 1 and group 2. And basically that is what we can see in this graph, so we can feel confident that we're interpreting that correctly. One of the reasons why these graphs and getting those means are also really helpful, just to make sure we're interpreting that the way we want to be. And so let me go ahead and write this up. And again, I really just like to do this in the SPSS file to just keep my notes really organized. And then obviously we'll transfer this later on to our paper if we're writing up our results, or to a poster if we're maybe presenting at a conference or something, or slides. And we also want to make sure to correct all the formatting, add all of the little bits of italics and anything else that we might need. Mostly it's the italics that SPSS doesn't always make quite as easy, although it should be. And so let me go ahead and write this up. So we have a one-way analysis of variance, is the full name of the ANOVA. Revealed significant differences between the groups. And so we're going to start off just with the results of that mean ANOVA before we get to those post hoc tests. We're going to have F, we're going to give our degrees of freedom, so 3,8 equals, that's 31.27. Value, p-value is, in this case, I'll say less than 0.001. And to give a little more context for how those means differed based on our post hoc test, say that post hoc test that group this sentence type 3 is faster than all of the other groups. And group 4 is slower than the other sentence types. Between groups. and 2. And so here again, we have this nice statement of my results. I can see if it will, good, so I'm going to italicize these. So we have our F value, we have our degrees of freedom, we have our P value, and we have the results of our post hoc test.